Welcome. This is Bible Maths, courtesy the Math Ministry at www.maths123.org. We are looking today at worksheet number 3, length of an arc or a circle. And let me congratulate you for reaching this far. Keep up the good work. What is God's word saying? In Psalm 23:3, it says, He restored my soul. He leaded me in the paths of righteousness for his name's sake. Isn't God a merciful and loving God? When we tend to stray, he leads us back to his love and his care. Why? Because he loves us very, very much, and he's doing that for his name's sake. Not because of what we may have done. It is all because of his unconditional love for you and for me. So continue to walk along that path of righteousness, and you will surely, surely be blessed. Question number 1. We are given the slice of a cake as shown, and you are asked to find the area, no, not the area, you are asked to find the length of the arc. And there is a formula for arc length, and that formula, let's use L, arc length. That formula is arc length L is equal to theta over 360 multiplied by 2 pi r. Okay, so in this question, we given r as 21, and the angle is 30 degrees. So therefore, if we are to make a quick sketch of that slice of cake, the angle here we know is 30 degrees. And the radius is 21 centimeters. And that's how we'll represent the diagram. So it means that this arc length here is what we are finding, and that will be 30 over 360 multiplied by 2 multiplied by 22 over 7 multiplied by radius, which is 21. So it's a good idea. We can use our calculator and work out everything there, but let's just break it down. 21 divided by 7 is 3. And let's work out that first part on the calculator. What is 2 by 22 by 3? That's 44 by 3. That'll give me 1 to the 2, and let's multiply by our 30. And then we can now divide by 360. Right, so we got an answer for arc length as 11. Did you get that? Well done. 11 centimeters. Question number 2. You're given a similar problem here, but this time we are looking at a pizza, and we are told that the angle here is 45, and we are asked to calculate our arc length if the radius is 9.8. So we go back to the formula. Arc length is theta, the angle, over 360, right? And so in that case, it's 45, and we multiply that by 2 by 22 over 7 multiplied by 9.8. And we will do that calculation on our calculator. Let's work it out. So we're going to divide 9.8 first by 7. 1.4 multiplied by 22 That'll give us 30.8. And then we are multiplying that by 2 again. 61.6. Let's multiply by the 45. And then divide our answer by 360. Final answer, 7.7. So that should be our arc length right there, 7.7 centimeters. Let's double check that working. .45 divided by 360, right? Multiply by 2 by 22 is 44. Multiply by 9.8. And then we divide by 7. Right, giving us 7.7 centimeters. Well done. So question number 3. Now, it's always good to see the connection between what we learn in here and what we actually experience in everyday life. So we are using slices of cake and pizza just to show you how this arc length is represented in our everyday life, okay? So here you're given a diagram and you are asked to find the minor arc if theta is 150 and the radius is 49, and then you're asked to find the major arc. So let's do that here. So let's work out first the minor arc. And I'll just put the word minor below here. This will be theta, which is 150 divided by 360. We're going to multiply by 2 by pi and by our radius, which is 49. So working that on our calculator, let's see what we get. 150 divided by 360. We're going to multiply this answer by 2, then by 44. No, not 44, sorry, by 22. All right, then by 49. And we divide it all throughout by 7. Right, I'm getting 128.3 recurring. So let's write it down as 128.3. Just to double check that working there. Always a good idea when you work in these problems to double check your answer. So let's go again. 150 divided by 360 multiplied by 2 by 22 is 44. Then we multiply that by 49. And finally, we divide by 7. Right, 128.3, one decimal place. So this will be the length of our minor arc. Now we also asked to find the length of the major arc. So let's put that below here, the length of the major arc. Now remember, we did say that if this is your minor arc here, right here, if this portion right here is your minor arc, then the major arc would be the remaining portion of the circumference of the circle. So going all the way back here, right, this will represent in green the distance around right there in green, right, that will represent our major arc. So let's work out our major arc, and we put in the angle here now of this major arc would be the difference between the 150, which is the angle for the minor arc, and the total, which is 360. So the angle we're going to be using here will be 210. That's the angle here. So therefore, we're going to put 210 over 360. So we are using the formula now. Multiply by 2, multiply by pi, right? And then we're going to multiply by the radius. And the radius we are told is 49. And we're going to bring out our calculator and let's work it. So this will be 210 divided by 360. Multiply this answer by 2 by 22 is 44. Multiply by 49. And we're going to divide now by 7. Okay, final answer, 179.7. 179.7. Let's double check. $179.7. Right. So if this distance here in the first answer we got, the minor arc is 128.3, and then this distance here is 179.7, then the total circumference should be 179.7 plus 128.3. So that circumference should be, let's add up that, right, 179.7 plus 128.3. I'm getting 308, right, centimeters. Okay, so we know that is going to help us answer part C of the question. So part C is saying find the sum of your answer in A and B. So we got it as 308 centimeters. And let's proceed to just confirm that. Let's proceed to confirm that by calculating the circumference. Circumference is 2 by pi by the radius, which we said was 49. Some could go into 49 to give us 7. So let's calculate what we have there. So 2 by 22 is 44 by 7. And we see our answer is, in fact, 308. Circumference is 308 centimeters. So we expect that. And we just give an explanation to part E. Should your answer in C and D, right here, answer in C, which is the 308, and the answer in D be the same, and the answer is yes. Why is that so? Because the circumference, and let's see if we could write that here, the circumference is equal to the length of the minor arc plus the length of the major arc, right? And we saw that just now up here. When we added the two lengths, we got the circumference of the circle, right? And we saw that right here. So I just wanted to give you that question so you could agree with me in terms of the circumference of the major and the minor arc. When added together, those two lengths, it will give you the circumference of the circle. Let's go to question number 4. Find the length of the arc of one of the sectors in the wheel of the chariot if the diameter of the wheel is 140 centimeters and theta is 60 degrees. Right. So you're given, they tell us find the length of the arc in one of the sectors. The theta here is 60, that's the angle. So what we're looking at really, and I'm gonna bring let's see if we have it. Right. So what you're looking at, right, is basically we're trying to figure out what is the, right, that's one of the sectors of your wheel right there. And we just want to find the length of this arc. Let's do it again. That's one of the sector in the wheel. And we just want to find the length of one of this, the arc there. So that's why I drew it like this. And let's calculate it now. So remember, each of these lines here represent the radius of the wheel. So if the diameter is 140 centimeters, it means that the radius is 70 centimeters. Why? Because diameter is equal to twice or 2 times the radius. So if we have that information we need on the radius, then we are in a position to find the arc length, which is L equals theta 60 over 360 multiplied by 2 by pi multiplied by the radius. All right, so let's calculate this here. It's 10. Okay, so let's use our calculator now. Calculator. 60 divided by 360 multiplied by 2 by 22 is 44 by 10 is 440. And that'll give us 73.3. 73.3 centimeters. And that'll be the distance for your arc length. And again, we show in the reality of our mathematics, when you actually pull back, and I'm looking at the last question now, when you actually pull back a bow, as in a bow and an arrow, you actually form something resembling your arc. And if you put these 2 lines here to represent your string of your bow, right, we know the arrow will be somewhere in the middle there, being pulled back. And that is what we're looking at right here, and we've seen it up here. And if you are given the length of the string as 112, now we got to be careful here. The entire length of the string is 112. So this distance plus this distance is 112. So therefore, it's something like the diameter. If the diameter, which is 2 times the radius, is 112, then it means that the distance we need in using the formula, let's work it, is really, so let's work it, and then I'll just show you something. We can manipulate that formula there. So diameter is equal to 112. Radius is equal to, let's divide that by 2. This will be 56 centimeters. And that is what we are using in our calculations. The radius as 56. So the length of the arc will be 120, which is the angle here, as stated in the question, as the angle 120 over 360. But the radius we use in 2 by pi by the radius of 56. Okay. So 7 could go into 56 8 times. And let's just work it on the calculator from there. $120 divided by 360 multiplied by 44. multiply by 8. I'm seeing 117.3. So that's what we're going to get in this answer, 117.3 centimeters. Very good. So I'm glad you were able to make an attempt, make an effort in solving these problems. Even if there were a couple of them that were a bit challenging, I am so happy that you were able to make that effort. Effort is everything. Don't give up. Be encouraged. God is, in fact, a great God. Okay, so in that last question, I want to show you something there. Remember, we were working with diameter, and let's just do a little review on the formula for the length of the arc. So this formula L is theta over 360 multiplied by 2 pi r. So 2 pi r is really our what? Circumference, which we said could also be represented by pi by diameter. So another method for working this last sum, if you know the diameter is 112, you simply put length of the arc would be 120 over 360 multiplied by pi multiplied by a diameter, which is 112. So it's just a slight variation of that. And let's double check the working. You should get the same answer of 117.3. So it's 120 divided by 360 multiplied by 22 multiplied by 112, and let's now divide by 7. Okay, so we get the same answer, 117.3. So we will end as we started by continuing to declare God's blessings over your life, that He restored your soul and He leads you in the path of righteousness for His name's sake. May God richly bless you. Bye for now.